Midsegments of Triangles. Kobe, you need to move. You don't sit there.
No. What?
Kobe, move.
No,
You don't sit there.
I think you can see.
Nah, I'm writing everybody. She don't sit there. She don't sit there.
Kobe, move. Go.
What?
Go over there. Go. Go. What?
Wait, Miss Alec, how about this? If I rock paper scissors, if I beat you
Bro,
rock paper
I'm
scissors,
putting my headphones on, bro. I'm gonna stay quiet and do my work.
You're not supposed to wear headphones.
Bro, all my I won't, bro. Chill. I'll be quiet, bro.
Take out your headphones and be quiet.
How can I take them off?
Like, just like.
Put them on the ear, bro.
There you go.
Then I won't be.
Oh, well, then go over there.
I'll be quiet.
Shut into the corner. Okay, anyways. Let's see how this goes. Okay, so for mid-segments of triangles, okay, a mid-segment of a triangle is a segment that connects the midpoints of the two sides of the triangles. So if you look at your triangle, it has the little dashes. This means that BD and DA are congruent. D specifically is the midpoint to BA. It's right in the middle. On the other side, you have two congruent sides. Take it out.
Bro,
Stop.
I can't see it.
I can stop it. No. You have BE and you have EC that are also congruent. Kobe, stop.
I just put on my hood.
Okay. Watch. Okay. E is the midpoint of the other side. So it cuts it in half to two equal parts. So you have something called a triangle mid-segment. So on your triangle, I want you to literally write mid-segment here. So this is the mid-segment. Then don't and fail. I don't care. Okay. So the example for the mid-segment is DE. It takes the two midpoints and it connects them and cuts the triangle basically in half. It's not two equal parts, but like it's cutting it in half. There's a line going through it. The triangle mid-segment theorem states that if a segment joins the midpoints of the sides of a triangle, then the segment is parallel to the third side and technically is half as long. So this line is parallel to the third side, which is the base. So DE is actually parallel to AC. So there's two formulas you can use that we're going to be using today. One is going to give you decimals, but it's going to end up as a whole number. One is going to use whole numbers the entire time. I'm going to show you both, but I'm going to use the one that uses whole numbers because I hate decimals. So let's say DE is technically equal to half the third side, which is AC. So DE is half the length of AC. Now, this is the one that you're going to get decimals for because you're cutting stuff in half. So if the number's not a even number, it's going to give you a decimal. The other formula you could do is you could technically take DE and you could multiply by 2. And it'd be equal to AC. That's the one that we're going to use because we're going to take the mid-segment, we're going to multiply it by 2, and it's going to be equal to the third side or the other, like the parallel side to the mid-segment. Let's go down to number 5. So for number 5, can anybody tell me what the mid-segment actually is?
thing before 7.
Yeah, thing before 7x. So this is right here. So 7x is my mid-segment. So what we're going to do to follow this formula is we're going to take the mid-segment. We're going to multiply it by 2. So we're going to say 2 times 7x equals what? Not 14x. But yes, the next step would be 14x. It's going to be, yes. So you're taking the point of this is you're taking, if you use your eyeballs in geometry, once again, we can use our eyeballs because most of it's drawn to scale. This is definitely not the same length as this. They are not the same. This one's clearly longer. So what we're going to do is we're taking the mid segment, we're taking the middle, we're multiplying by 2, and we're equaling it to the bigger side. And now we can solve. So 2 times 7x is what Klesty said, which is 14x. Solve for x. It's a 2-step equation. Easy peasy. Yep. So we're going to minus 17x to both sides. Nope. Oh, yeah, like over there is -3, yeah. I thought you meant like the answer. Like, no, that's not the answer. So what do we get? 6. Okay, so using that same method, try to set up number 6. You're taking the mid segment, you're multiplying by 2. Yes. So you're taking the mid segment, you're multiplying by 2. So that's going to go in parentheses. You will have to distribute because it's going into both terms. So try to write your equation. You're doing 2 times 6x plus 31.
So you're making 2.
Don't get any wrong, you get them all right. So 2 times 6 is
Twelve.
what's called, 12 eggs plus 31. Wait, 2 times. But do I do 2 times 31?
Yes.
62.
So you do have to distribute into the parentheses. So take a second, solve for x if you haven't done so, or if you're still working on it. It is 14. That is correct. Very nice. Is that what we got? Yeah.
What you said?
I'm gonna say y in my.
Yeah, okay. Anyways, so we take the middle, we multiply by 2. Now we're going to use the same concept and we're going to kind of like work backwards through these problems. So we're going to go back to number 3. Now, if you look at number 3, there's a triangle and then it looks like there's a triangle like inside the triangle. That's because there are 3 mid segments in this problem. There's only 1 mid segment in this problem. There's 3 in this problem. So each side of the little triangle is a mid segment to the bigger triangle. So we're going to go back to number 3. It says if LM and N are midpoints of the sides of triangle PQR, we're going to put these on our picture. P to R is 46. And this is where the different colors might help you. So P to R is 46. It says PQ is 40. So this side's 40.
What PQ is 38 actually?
It could be, but in this case, it's not. And then the last side is going to be LN is 17. LN is this right here, which is actually in the triangle, which is 17. So we just talked about mid segments. There are 3 mid segments in this same problem. So if PR is right here, what line is actually parallel, or what is the mid segment to PR? Not QR. What'd you say?
N.
It's not N.
Well, you said the mid.
What's the mid segment to this bottom piece? LM. Okay. So if this whole thing is 46,
Isn't it
hold on, wait. Shh. If this whole thing is 46, what's the mid segment for LM?
N?
If this is 46, let's think about what we just did. We took the mid segment and we multiplied by 2 to make the outside. If I know the outside's 46, you divide by 2, 23.
Understand it now.
So if this piece, PQ, what's the segment that's the mid segment for PQ? What is PQ parallel to?
LN.
Not LN,
N.
NM. So these match, but they're not equal. If that's 40, what is this? No.
Wait, so it'd be, wait.
20.
No.
Fuck these,
Oh,
bro.
yeah, because like,
Okay, because you're taking the outside and you're cutting it in half. We took the mid, shh, let me talk. The mid segment, you multiply by 2 to make the outside. So 23 times 2 makes 46. If you're given the outside, you're dividing by 2 to find the inside. So now the last side I have is right here. LN is parallel to QR, which is 34, because you have the small piece. So instead of cutting it in half again, you're making it bigger, so you're multiplying by 2. So you're either multiplying by 2 or dividing by 2. You have to think they're not equal. Do you need the small piece? You divide. If you need the big piece, you multiply. So try to fill out all of these. Take a second. What is MR? Half of 34, because technically the whole point of this is M is the midpoint. So you cut it in half. So it's 17. So try number 4 with that same kind of concept. No. Try number 4. Same type of problem. Yep. I'm so serious.
Solid.
Not that bad.
Honestly, how is this gonna?
It's like a puzzle.
Help us.
The geometry is about, it's less about like the math and like the real world application. It's more about problem solving. Like legitimately like working through.
It's gonna help you.
Are these the papers you need?
No, not Bristol. Yes.
If they were to do like,
Also, can you spell?
like,
Yes. Put your phone on.
putting all the.
It's on my dad.
Okay.
Like, you know, with that,
It's like a big puzzle. Yeah, that's literally, it's like a math puzzle. Huh? That's like those gifted classes from middle school. If you were in the gifted program.
Okay, but CEB with a GH.
Wait, I know what it is.
None of the pieces are equal
Like,
technically.
what I've been doing the math with CH. I mean, BH.
GH goes with CE.
Yeah,
They're not the same.
I double it.
Is DE, is DE.
Okay, I can understand.
Yeah.
Oh
Hmm.
my gosh, I'm so fucked.
This is like the triangle.
FH is 12.
It's this way.
I don't-
It's right here.
Hold on. I have no idea. I have to like put these numbers.
It's 14.
Like right here.
Wait, so 8. Oh my gosh, wait, I'm actually there.
Triangle is facing this way.
Wait, fuck me, bro. Fuck me.
Down here.
Would you find the perimeter? Do I just I just add all of it together?
All the sides.
Like shit. 28, so 14 is 38 plus 18 is 56.
Would,
Oh my god.
but would, wait. Would
You're genius.
F be the midpoint of CD?
What'd you say?
Would F be the midpoint of CD?
What did you get 14 for?
Yeah.
So it's solid.
I got 14 for CE, bro.
Yeah, that's the right answer. It's solid.
Oh,
CD,
okay.
why times 9?
I don't know. I just used my fucking.
Yeah. Okay.
Alright, so what you want to do?
The whole point of this is finding the parallel side. You take the parallel side, you either cut it in half or you divide or you multiply by 2. So like either dividing by 2 or multiplying by 2. So yeah. Okay, let's go. Let's just go in order. CE is finding this piece. What is that parallel to? GH. So if this is 7 and I need to get bigger, I'm multiplying by 2. So what do I get? 14. Yeah. No, you add the sides. Okay. The next one says DE, which is this whole piece out here. That's parallel to GF. So what is that going to be? Not 24. 18. Because you're multiplying 9 by 2 to make the outside. FH is right here, which is on the inside. That's parallel to the 24, but you're getting smaller.
Is it 12?
It's 12. The last question is you want to find the perimeter of the entire triangle. So it says find the perimeter of CDE. So you're not using every single number. You're adding up all the outside numbers. So 24 plus 18 plus 14.
Guess you got that answer.
You did. Okay. Let's go up one more time. We're going to go to question 1. Question 1 wants to know basically which pieces actually go together. Which pieces are parallel, what is the mid-segment, and what is like the matching line that goes with it. So we're going to name all the parallel segments. So if I say QR, because it technically doesn't matter which one goes first, what does shh? This is my problem with you guys. Kobe,
I'm not even going to.
you're literally,
I broke the one that got
you're
already done.
literally talking. Okay. QR matches with what? Nope.
WY.
WY. So we're looking for the mid segment and then the long piece that goes with it.
How about I said the other?
What does RS match with?
XW. Too slow. Or is that your? No, it's weird.
And
bro, why?
If I say XY,
QS.
QS. Yes.
Oh, what? What's a cakewalk gonna be?
So you're just listing the parallel sides. Let's.
Why shouldn't it be QS equals XY?
It could be. That's why I did that. So you could list them backwards. You could do the small piece first or the big piece. You could put the letters backwards. As long as it's the matching pieces, it's fine. Let's go to the back side. So all we've done so far is the side lengths. What we're going to do now is on the back, we're going to talk about the angles inside the actual triangle.
Wait, what is triangle mid segment for number 2? On the front.
Number 2, you're just like what we just did, identifying the parallel
No.
lines.
Two.
Yeah.
Up one. Up one.
Oh, 2 times DE equals AC. So we're going to go on the back. We're going to do number, I forget what number it is. I got to flip my paper. Okay, we're going to do number 10. So number 10 is now angle measures. That's why it says the M and it's got the little inequality looking thing. It says the measure of angle 1, the measure of angle 2. So now we're talking about the inside. You have to think outside the box here, outside the triangle. A triangle adds to make 180. Keep in mind a line adds to make 180. Okay, so all these little pieces from throughout the year are going to kind of come into play. So technically we have 59 here. We have 127 here. Does anybody see something that we could do? I don't want to give it away. Okay, so Tyler said that these two add to make 180, specifically 127 and angle 2 add to make 180 because they're a linear pair. So if I take 180 and I minus 127, what do I get?
63.
So I'm put, oh my God.
53 or 63? I don't know.
Can somebody check him?
I was 53.
Thanks.
I'm kind of nervous with this.
This is the hardest type because it's like not really math. It's like problem solving. So 53 can go there. Now, technically, we're talking about parallel lines cut by a transversal. 53 can go in one other spot. Does anybody see where else 53 could technically go? Not 5, not 4, 1. The reason why is because this is a line that's parallel to this line. So corresponding angles say that I could put this one here. So these ones are congruent. So this is where if you have a different colored pen, I would mark this. These are congruent to each other. 1 and 2 are congruent. If you have a different colored pen, you can mark these ones with 2 arcs. Shh. Kobe, stop. 5 matches with something. What does 5 match with? 4. I mean, no, 5 doesn't match with 4. No. Hold on, wait. Shh, stop talking. 4 technically matches with 59. 53 can go here, 53 can go here. They're corresponding angles. Same thing with down here. 59 can go here, 59 can go here. So automatically I could put 59 here. Because corresponding angles with parallel lines.
I thought it'd be like a little.
Yeah, so now we're going to do equal to 180. So if I take 180, I minus 59. What is it? So this is 121. Okay. And now we need to find the last angle, which is technically angle 3. Does anybody see what you could do?
9.
Because this is a triangle adds to make 180. So you have 59 and 53 plus something that makes 180. So what is that last triangle corner? 68. So angle 1 is 53 degrees.
What did you just say?
Okay.
Okay, we're gonna set up 2 more problems and then that's it. And then you can just work on the rest of them. So the last 2. Shh. So why tomorrow you're not sitting?
Not even just me, bro. Freaking y'all trip too, bro.
I know, but you're the problem.
He's
Because
just
you're
distracting
wobbling
me.
over there.
He's
He's
looking at
in his corner.
Look what he's putting on my desk.
Nah, bro, that's it, bro. Don't you put it as putting me on people with balls, bro. Literally, been-
Okay.
I get in trouble when I say something.
Oh my God, just be quiet. 12 and 13. These ones are both angles as well. So my hint for you are they either equal to each other or they add to make 180. So in this case for number 12, we're not going to do this one together, but like, do you think these angles equal to each other or do they have to make 180? Yeah, because technically they're corresponding angles. So we're going to set them equal to each other because they're both acute. No, that's sides. For number 13, notice that this one is acute and this one is obtuse. Technically, you could put 5x plus 2 right here next to it, and then they're linear pair. But I'm not going to do that because I feel like it's confusing. Just look at them. They're different. This one's acute. This one's obtuse. They are not the same. So I'm going to add them to equal what? 180.